We all have seen the compass at least once in our lifetime. We also know that the red needle points out the north direction. But do you know that our compass never shows the true north? Yes, magnetic north is not same as the true north and has never sat still. The change might be small, yet in recent years scientists noticed something unusual, which is the magnetic north started to shift into high gear, sending it racing across the northern hemisphere. And no one can entirely explain why. And now you may ask me, what? North is no more north now? Yeah, even I was shocked when I first heard of it, and that's why I am here to explain the cause of this magnificent phenomenon. The change might be small, but it's not zero. After a long time of notice, the accumulated changes have been so large that scientists began working on an emergency update for World Magnetic Model, the mathematical system that lays the foundation of navigation from cell phones and ships to commercial airlines. Earth's geographic North Pole and magnetic North Pole were first recognized as two different places in 1831. Until the early 1990s, the magnetic North Pole was known to lie some 100 miles south to true north in Canada. Its present speed is about 50 to 60 km a year towards Siberia. Recently, the wait for a new magnetic north is over. The World Magnetic Model update was officially released finally. The magnetic north can again be precisely located for people around the world. Questions like why is magnetic north changing so fast? What were the impacts of the update's delay might be pondering in your minds, but don't worry, I have got you covered. First of all, what is magnetic north? It's one of the three north poles on our globe. First, there's true north, which is the northern end of the axis on which our planet turns. But our planet's protective magnetic bubble or magnetosphere isn't perfectly aligned with this spin. Instead, the dynamo of Earth's core creates a magnetic field that is slightly tilted from the planet's rotational axis. The northern end of this planet-sized bar magnet is what we know as geomagnetic north. Then there is magnetic north, what your compass locates, which is defined as the point at which the magnetic field lines point vertically down. Unlike geomagnetic north, this portion is more susceptible to the surges and flows of the liquid iron in the core. These currents tug on the magnetic field, sending the magnetic north hopping across the globe. As we discussed before, the geographic north and south are the axis of Earth's rotation, whereas magnetic north and south are based on the planet's magnetic field. In the last 150 years, it has wandered about 1102 kilometers. It's all because of the Earth's physical structure. Yeah, the Earth's physical structure is behind all this magnetic shifting. The planet's inner core is made of solid iron. Surrounding the inner core is a molten outer core. The Earth itself spins on its axis. The inner core spins as well, and it spins at a different rate than the outer core. This creates a dynamo effect or convections and currents within the core. This is what creates the Earth's magnetic field. It's like a giant electromagnet. Exactly how the dynamo effect changes the field isn't widely understood. These changes might also cause the poles to switch places. Irregularities where the core and mantle meet the changes to the Earth's crust, like the large earthquake, can also change the magnetic field. The magnetic North Pole is responsible for more than just the direction of a compass points. It is also the source of auroras, the dramatic light that appears when solar radiation bounces off the Earth's magnetic field. This happens at South Pole as well.
Learn something.